constant type of supply. On the other hand, AC supply, which is alternating quantity, varies from positive to negative in a cycle. Here MATLAB Simulink is a software which is used to simulate electrical circuits, as well as it is very user-friendly software for other type of technical works. So first of all, I must tell you how to start modeling in MATLAB, and through which I will teach square wave inverter and multi-level inverter. First, open MATLAB from here, and then go to file menu, or you can also use from taskbar. This is a file menu, or open any type of prior saved model, and if you want to draw a new model, then you have to click on new and then Simulink model. Then there is an untitled model open in your screen. First of all, we have to simulate for sine wave and a constant wave. This is the icon for Simulink library. If you click on this Simulink library, this Simulink library is open. And there are so many useful blocks present in this Simulink library. If you want to make a proper circuit, you have make a proper circuit using this Simulink library. This is commonly used blocks in which there are sink and sources, which is very important for any type of system. These are the scope, sine wave is also there in sources. These are number of sources, many number of sources, many type of sources. These are the sinks through which we can see the output, our output. So when we just simulate the a sine wave, just click on this icon, add to untitled, and it will present automatically in your untitled window. Then you have to check your response through the scope. So click on sinks, click on scope and add to untitled. Now scope is connected with your sine waveform here, like this. When you run this, it will take some time, but you will get sine wave from this scope. So the main purpose of the inverter is to convert the constant DC waveform to the alternating quantity. So let's talk about our square wave inverter. In square wave inverter, there is many types of inverter, half wave, half edge bridge inverter and full edge bridge inverter. I am here to talk about full edge bridge square wave inverter. So this is the model of full edge bridge square wave inverter, in which there are 4 IGBTs. IGBT is insulated gate bipolar transistor. This is the gate pulse, which is given through the pulse generator. Pulse generator is also in our Simulink library browser. These are the freewheel diodes, which is connected to this IGBTs. And this is the DC voltage source, I am taking 100-volt DC supply. If we want to change, just feed the value here and it will change. These are the pulse generator, which have amplitude, time period, pulse width, and phase delay in it. I am using 4 pulse generator for a single H bridge inverter. In this, you have seen clearly that there is no any phase delay. But in this case, there is a phase delay of 0.000625. Actually, I have divided this frequency, this time period 0.0025 in 8 parts. And when we delay it, we can simulate for sinusoidal waveform. Here delay is 0.00125 and there are different delay in this 4th IGBT 0.00185. I am running this model for resistive load. We can also connect inductor with this resistor. Then we will run for RL load and so on. Currently, I am running this model for resistive load. This is the simple H circuit of a square wave inverter. When you run this, here it is compiling. First it is compiling here. Now it is compiling. It's compiling. From where we can get these all elements? I have already shown you all from where we get these all elements in previous lecture. It will take some time. I am running this model for this 0.001 second. It is completely depend upon the frequency of this pulse generator. Now this is complete, and when we check the output of this square wave inverter with the help of this scope, we will get this result. This is the quasi square wave output of the inverter. Now you can see clearly that this is positive peak and this is the negative peak. This is -100 and this is +100. So this is all about square wave inverter or quasi square wave inverter. When we use only 2 pulse generators, then we will get a square wave inverter. What is the difference between square wave inverter and quasi square wave inverter? In quasi square wave inverter, there is an extra step we can get here. But in square wave inverter, it is suddenly goes from positive to negative. There is no any this type of step. That waveform is known as two level waveform, and this is three level waveform. First level, second level, and this is your third level. Now it is very simple to learn and understand the concept of multi-level inverter with the help of these square wave inverters. When we cascade the output of two square wave inverter, we can get a multi-level inverter very easily. But you have to keep in your mind about the phase delay of this pulse generator. And because of this cascaded multi-level inverter, I divided this 0.0025 second into 8 equal time period. And now this 8 pulse generator have equal phase delay, equal phase angle from each other. So this is of 0.0025, this is the frequency, this is the phase delay. This is all about your pulse width modulation. This is also known as pulse width modulation. But in that case, you have to compare triangular carrier wave with the sine waveform. I am trying to show all these switching pulses in a single window, so you can find the difference of the switching waveforms. This is your third, this is your first, this is your sixth generator, pulse generator, this is your fourth pulse generator. So we can clearly, it is clearly shown that the phase delay in this first pulse generator is 0 second, phase delay in this second pulse generator is 0.00125 seconds, and the phase delay in this pulse generator is 0.000625, and the phase delay in this pulse generator is 0.001875. So these four pulse generator have different phase delays. Now when we talk about lower switches or lower square wave inverter, it is shown that this is the most important thing of the square wave inverter or any type of inverter. Switching is the main reason to get the proper output. Now I am placing all the pulse generators in a single window for you to find out the difference. Now you can see that the phase delay in this is 0, phase delay in this pulse generator is 0.00125, phase delay in this generator is 0.000625, phase delay in this pulse generator is 0.001875, phase delay in this pulse generator is 0.003125. It is just the 8 equal part of 0.0025. The phase delay in this pulse generator is 0.0015625 and phase delay in this block is 0.002175 and the phase delay in this pulse generator is 0.0009375. This phase delay is done keeping in mind that every switch opened at a time when this switch is open, all the switches are switched off. This is totally depend upon the frequency. How many, when to switch which switch, when to switch which switch is totally depend upon the switching, and your output is totally depend upon the switching you have done for your inverters. Now this, when we run this from here, I have already run it. This is also a quasi square wave output of this lower H bridge inverter. When we use this sum block to cascade the output of these two inverters, we will get the output of our multi-level inverter. And it is very important to know that what will be the number of levels you will get from these two H bridge inverter. So I am telling you that there is a relationship between the number of sources and number of levels. If there are two number of sources, the number of levels are 2n plus 1. So in this case, there are two number of sources. So the number of levels are 2n plus 1, means 2 into 2 plus 1. And we will get a 5-level output. This is the 5-level output using cascading two square wave converter. This is the first level, this is second level, this is third level, this is fourth level, and this is your fifth level. And we can see that this is approaching the sine wave, and when we increase the level, we are heading towards the sine wave. And the sine wave is the best wave form for our AC appliances. The number of harmonics are reduced in this multi-level inverters, and we are not using any type of filters in multi-level inverters. So the design of filter is also not required in this multi-level type of converters. So I am telling you now from where we get all these elements, and other features of the MATLAB. From Simulink library, you can get all the elements. These are the simple sinks you can get from here, sinks. And if you want to get sources, you have to click on sources and you will get sources. These are the sources. Constant is there. We can use constant for DC supply. If the very important tool for electrical engineers is sim escape. When you click on sim escape, there are so many tools in sim escape also. I am using sim power system. So these are the application libraries. There are application libraries, control and measurement, electrical sources. We can get DC sources from electrical sources, AC sources from electrical sources, voltage source, or any type of current source we can easily get from electrical source. These are elements. These are various electrical sources: AC current source, AC voltage source, battery, control current source. I am using DC voltage source in my multi-level inverter. These are various elements: RLC branch, RLC load. This RLC load is used in square wave inverter for resistive load. These are some measurement ports, like this is ammeter, which is used to measure the current. This is voltage measurement block, which is used to measure the voltage. These are the power electronics element, in which there are so many number of switches. I am using IGBT for square wave inverter. There are so many modular switches also available in this MATLAB simulator. And it is very easy to get these switches in your window. Just to add to multi-level inverter, or just go to parent, or just add to untitled, you will get this multi-level, you will get this IGBT switch. There is an option of help for every block. So if you want to know about any block, just click on help and you will get to know about IGBT in this case. So I think this is all about this multi-level converter. And in next class, I will teach you PWM switching. Okay, thank you.